Hi everyone, I just wanted to go through the basic understanding of an Atwood machine here quickly, just so you know what the formulas are that we're using, how to set these up. So an Atwood machine was created in order to analyze connected objects. So if I were to look at this apparatus over on the side, and I'm going to cross this out, and this because we're using W. So if I look at this, it's a pulley system, and the part on the left wants to go down because of the weight of itself, gravity pulling it down, and the one on the right wants to also go down. I call that weight too. If I did F net for this, then the forces are both going downward, but they can't both go downward. One has to go up and one has to go down. So in order to analyze these, we have to lay them out flat. So I've laid them out flat, and then I've put in the forces that are acting on them. So it's still, even though weight acts downward, when I lay this whole apparatus out flat, weight is to the left, the weight of the first one's to the left, and the weight of the second one's to the right. Anything to the right is still considered a positive direction. So when we do our F net now, it is simply still all the forces to the right minus forces to the left. So it's weight 2 minus weight 1. Or if I make my substitutions, it's mass times acceleration, but it's both masses because they move together as one object. Times the acceleration equals mass 2 times gravity minus mass 1 times gravity. Gravity is still considered a positive value because we are assuming a negative in our direction, so that covers the negative part. So this is what you need in order to solve these. When a lot of the questions will ask you for the tension in the rope. So the tension here where I've cut it, if I put in a scale right here and right here, that force of tension is going to be the same no matter what. It changes direction over the pulley, but the force of tension is the same all the way through that string. So if you're going to try to find that, when we want to solve the force of tension, we have to look at each block individually. So now if I look at mass 2, weight 2 acts downward, force of tension is now. So imagine cutting the rope. So this would still be all the force in the positive direction, which is force of tension minus whatever the weight is. And it doesn't matter if it's this one on the left or this one on the right. Tension's up, weight's down. If I make my substitutions for this one, I get mass 2, and it's not the same F net I found above. It's just the mass of the one object, or the same over here. The only difference is if this is the heavier one, it's going down, so the acceleration is going to be a negative value. On this side, it's going up, so the acceleration will be a positive value. When you put the positive and negative in here, that makes up the difference here and gives me the same force of tension for both. So there's a couple notes down here. Like I said, the F net is based on only the one mass. It's not the same as the net force above. That is the summary of what you need for 2 hanging masses of an Atwood machine. I'll make another video for the one with on a surface in a moment. Thanks.